Welcome to my video on addition rule of probability. So in this video, I want to go over the addition rule, which combines probabilities of two events, and it helps calculate the probability that at least one of the two events occur. So we're dealing with things with more than one event occurring, possibly at the same time. So as a general rule, for any two events, A and B, the probability of A union B, or this can be read as the probability of A and B, is equal to the probability of A plus the probability of B minus the intersection of A and B, or A intersection B, which this would be the graph right here. Here's your event A, that's the probability space of that. Here's B. Now if we want to take the union of the two, to avoid double counting this area right here, the intersection, we have to subtract that off. So that's all that's showing us here. So we subtract A intersection B to avoid double counting the outcomes of probability A and B. Now if we look at mutually exclusive events, this is a case where A and B are mutually exclusive. They cannot occur together. So in this case, the intersection is 0. Right, there's your Venn diagram. The intersection is 0. They don't overlap. And so the probability of A union B is just the probability of A and the probability of B. So an example would be like rolling a die. So A is the event, an even number, B is an odd number. So when you roll a die, 1 through 6, you can only get those 6 numbers, and they're all equal probability of being odd or even. So that you can't be together. You can't have an odd number and an even number. Since A and B cannot overlap, A intersection B is equal to 0. So let's look at a case here. An example. A is the event of rolling an even number, so that'd be 2, 4, and 6. So we know the probability of A, which is the number of favorable outcomes, divided by the total of possible outcomes, which is 3 divided by 6 is equal to 0.5. Now let's take a second event, the event of rolling a number greater than 3. So that'd be 4, 5, and 6. We also have 3 outcomes that are favorable divided by 6 possible outcomes, so the probability is equal to 0.5. But we have an intersection here. We've got 4 and 6 that are even numbers, and they're greater than 3, so we have to subtract that off. So the probability of A intersection B, so there's 2 favorable outcomes, which would be 4 and 6, divided by the 6 possible outcomes of rolling a die. That's equal to 0.333, or a third. So the probability of A union B, which is the probability of rolling an even number and a number greater than 3, so that's the probability of A plus the probability of B minus their intersection, which is a third, or 0.333. So that's approximately equal to 0.667. This is a continued fraction here, so it's got a bunch of 3's out there. But we can round it to 0.667. Now let's look at an example of mutually exclusive events. Consider rolling a fair die. The event of rolling an even number, so we just talked about that, that's equal to 2, 4, and 6, so that's equal to 0.5. This was the earlier example where we had an even and odd numbers of rolling a die. So that's 1, 3, and 5. These two don't intersect at all. They're mutually exclusive events. In other words, one can't occur at the same time the other one occurs, so both have probability of 0.5. Since no outcomes overlap, in other words, their intersection is equal to 0, thus the probability of A union B is equal to 0.5 plus 0.5 is equal to 1. And so that makes sense. If you roll a die, you only have 2 possible outcomes, an even number or an odd number. So if you take the union of both of those, it's got to be equal to 1. So what have we learned here? The addition rule calculates the probability of A or B occurring. As a general rule, the probability of A union B is equal to the probability of A plus the probability of B minus their intersection, the probability of A intersection B. When the events are mutually exclusive, in the case where we had an even and odd number on a die, the union of those two possibilities is just their summation, the sum of the two possibilities or probabilities of A and B. And so this addition rule is very handy for handling overlapping events and probability which do occur. Well, I hope you got a little bit out of this video and learned a little bit more about probability, and thank you for watching.